So we've already seen that when we start with our bracketed form, when we're expanding, we times each number on the outside by each of the things inside in turn. So 2 times the x would give us 2x, and 2 times the plus 4 would give us plus 8. Now this way, starting with the bracketed form, is us expanding, getting rid of the brackets to turn it into something that doesn't have any. We're sort of stretching it out, making it bigger in the sense that we are writing down what's actually there. Now for anything in maths that we can do, it's very helpful if we can have a way of undoing it. If we can switch from this form to this one, we also need a way to do the opposite and start here and put the brackets back in. Now if we're going to do that, if we're going to go from the expanded form back to the one that has got brackets in, that is us going through a process called factorising. And factorising is a fancy way of saying putting the brackets back in. Now to do that effectively, to have a nice simple way of doing that that works every time, what we're going to do is we're going to think back to something from a long time ago. So this is a quick revision question. And the revision question is, write 72 as a product of prime factors. Now when you see those words product of prime factors, hopefully you think one thing and one thing only, and that one thing that you should think is a single word, the word tree. Because write 72 as a product of prime factors, or in fact write any number as a product of prime factors, means we start with the 72 and we look to split it into 2 branches. Where at the end of each branch are 2 things that multiply together, 2 things that times together to give us the 72. We can go for any we like, but let's go for 2 and 36. Now the 2 is a prime number, so we're going to circle that because there's nothing else we can do with that. We're not interested in that anymore. But the 36 isn't, so we can split that. Why don't we split that into 6 and 6? Neither of which are prime numbers, but this 6 here we could split into 2 and 3, and this one here we could split into 2 and 3. And in each case, 2 and 3 are prime numbers. What we've done is we've reached the end of every branch. And the final step would be to write down 72 was equal to 2 times 2 times 2, 2 times 2 times 2, times 3 times 3. Now what we're going to do is we're going to start off, we'll start off with the 2x plus 8 so that we can, because we already know what the answer to that is going to be, and it's a fairly simple one. We're going to start off with the 2x and the plus 8, and what we're going to do is we're going to look at each term and we are going to break it down in exactly that way. I'm going to start with the 2x first. So the 2x, first of all, we're going to split into number and letter, and then for each branch, we are going to circle the end of the branch if it's a prime number or if it's a letter on its own that cannot be separated anymore. 2 is a prime number, so we're going to circle it. X is a letter on its own, so we're going to circle it, and that's the end of both branches reached. And underneath, I'm going to write down the 2 things at the ends of the branches multiplied together, 2 times x. So we've taken that 2x, we've ripped it apart into prime numbers and letters on their own, and we've written it underneath as 2 times x. We'll do the same for the 8, use a different colour. So the 8, I'm going to split that into 2 times 4, 2 is prime. The 4, I'm going to split into 2 times 2, both of which are prime, and we've reached the end of what we're looking at. And underneath, 2 times 2 times 2. Well, so what? We need a little bit more structure to this. We're going to use these to help us work out what goes where, but we need a basic structure. Well, we know that if we are factorising, for the question would say, nice and simple, factorise 2x plus 8. If we're factorising, we're going to be putting some brackets in. We know that we will have something here on the outside of the bracket. and we know how many things we will have inside the bracket. There are two terms here, and like we were talking about in the expanding, if there are two terms here, then there will be two terms here. There will also be a symbol in the middle, and it is very likely in most cases to match the symbol here, so we can put the plus in there. We just need to work out what goes here, and what goes here. Now what we're going to do is we're going to look at these strings of numbers times together underneath, and we're going to look for stuff that turns up in both. There is a 2 here that can be directly paired up with a 2 there. So what turns up in both lists? The number 2, as in a single 2. 2 is common to both lists. So that is going to go on the outside of the brackets. Just once, notice I'm not doing 2 times 2 because there isn't a 2 times 2 in both lists. There is just a single 2 that turns up in both lists. 2 is common to both lists, 2 goes on the outside of the brackets. The stuff that's left from the green first term is going to go in that space there. So what's left that we haven't used, well, we've used the 2, the only thing left is the x. In here, the stuff that's left from the purple second term is going to go in that space there. What's left, we've already used this 2 that's been underlined. These 2 here, this 2 times 2 in fact, is what's left. 2 times 2 is 4, and 4 is going to go in that space there. Final thing we should do to check, well, final 2 things we could do to check. First of all, there is nothing that they have in common. There's no extra factors that we've missed, because if we're factorising, we should be factorising fully. And in fact, the question might sometimes say factorise fully, as in, make sure there's nothing that these 2 have left in common by the time you've got your factorised form. Second thing we can do is we can check by expanding. We don't necessarily have to write this down, we can if we wish, but we could just in our heads do 2 times x to get 2x and 2 times the plus 4 to give us plus 8, and everything works. What we've done here is we've started with an expanded form, we've gone through this process inspired by our product of prime factors, and then we've ended up factorising the question. We've put the brackets back in. Let's do a slightly more complicated one. So again, straightforward question in terms of how it's asked. Next of our keywords are factorise, as in put the brackets back in. Let's go for factorise 6x squared plus 12x. Looks a bit more complicated, and I suppose it is because we've got the power in there, but we can still go about things in exactly the same way. We could still set up our blank brackets. We're going to have blank brackets and a plus in the middle. We've got a space for something here, space for something here, and space for something outside. We're going to deal with each term one at a time, and we're going to split them up into, first of all, numbers and letters. So for this first one, the 6x squared, we're going to ignore the 12x for the minute. Split it first into 6 and x squared. We can only circle it when it is a prime number, i.e. one that we can't split up anymore, or a letter on its own. Neither of those are that just yet, so we're going to look at the 6 first, and then we can split that into 2 and 3, both of which are prime, so we could circle them. X squared, we can split simply into x and x, because x times x is x squared by definition. Both of which are single letters, we can circle them. Underneath, 2 times 3 times x times x. There's that first one done. Second one now, we can split that up however we like, but we're going to first of all have to start off with the 12 and the x. X is a letter on its own, so we can circle that. 12, however, we can split, so we want 2 things that times together to make the 12. Doesn't matter what we pick, of course, much like with the tree. We can go through any set of correct answers that we like. We'll always end up with the same answer at the end. So let's go 2 and 6, and then 6 into 2 and 3. The 2, and the 3 all being prime. So underneath, 2 times 2 times 3 times x. Now, what we're looking for is we're looking for stuff that turns up in all of the terms. They may not necessarily all be in the same order, but here we clearly have a 2 times 3 times x, and here we also have a 2 times 3 times x. Notice that if I had written these in a different order, if, for example, I had written 2 times x times 3 times 2, then I wouldn't have had the 2 times 3 times x, because nowhere in this is that written, but I still have the 2, the 3 and the x in an order somewhere. There is still somewhere in there a 2, a 3 and an x that are clearly all being times together. The order does not matter. What matters is the things that are in both. So really, it might be easier, or perhaps better, to instead write that there is a 2, a 3 and an x, a 2, a 3 and an x. So the stuff that turns up in both is 2 times 3 times x. Now 2 times 3 times x is 2 times 3, 6 times the x is 6x, and 6x is common to both. So 6x goes on the outside of the bracket. The stuff that goes here is the stuff left over from this purple one. We've used the 2, the 3 and the x. The only thing that's left is, in fact, that x there. And from the second one, we've used the 2, the 3 and the x. The only thing that's left is that 2, so that green 2 can go in the second position in the bracket. When we've done, and we think we've factorised, and we think we have 6x into x plus 2 in the brackets, we should check that the x and 2 have nothing in common. Well, one's a letter on its own and one's a prime number, so that's it. There is nothing that they have in common. And if we did 6x times x, we would get 6x squared. The x times x giving us the x squared. And if we did 6x times the 2, the plus 2, in fact, we would get plus 12x. By expanding, we get back to where we started, so we must have factorised correctly. Always worth doing that check, because if we check and it works, that is one more of those questions that self-checks nice and easily. Factorising and expanding, you can always do the opposite to check it. Once you're comfortable doing both, you can check by doing the opposite of the one that you're doing. If you check it and it's correct, that's one less thing you have to come back to later. Factorise 10ab squared minus 15b. A little bit more complicated because we've got quite a lot of stuff going on, but we can still set ourselves up with 2 blank brackets, and there'll probably be a minus in the middle this time because it's likely that that minus will give us a minus in there. We're going to go through the same process. We're going to first of all split this up into the 10 and the ab squared. Let's focus on the 10 first of all. We can split that further into 2 and 5, both of which are prime numbers. And the ab squared into a and b squared. We're happy with the a, but the b squared we can split into b and b. Underneath, 2 times 5 times a times b times b. And then for the minus 15b, well, 15 and b, b's okay, but 15 into 3 and 5, both of which are prime, so we can circle them, and underneath, 3 times 5 times b. To work out what goes on the outside of the bracket, we look at the 2 lists and we see what they have in common. Well, there is a 5 turning up in each, and there is a b turning up in each. That's it, because we have to go for direct pairings. There is a b here, but there is no b to pair it up with here. There is a 3 here, but there's no 3 in here at all to pair it up with. So that goes on the outside of the bracket. What goes on the outside of the bracket, in fact, is 5 times b, because notice that these are all times together. These are all times together. 5 times b turns up in both, even though they are not actually next to each other here. They are here, coincidence, they are not here, but it doesn't matter, they are still being multiplied together. So 5 times b, which is 5b, goes on the outside of that bracket. The stuff that's left from this purple one goes in the first space, the stuff that's left from the green one goes in the second space. So after we've taken the 5 and the b out and used them on the outside of the bracket, what we're left with is a 2, an a and a b. They are still all being times together. So 2 times a times b will be 2ab. And in the second space, the stuff that's left is just a single 3. So that's going to have to go in the second space. We need to do those 2 checks, because if we can do those 2 quick checks at the end, then we know we're right if the 2 checks are successful. So the first check, we're going to check that 2ab and 3 have nothing in common. Well, there's letters in here and no letters in here, so that's good. 2 and 3 are both prime and have no factors in common. There is nothing they will both divide by, so we're okay with that. If we were to do the expanding, however, if we were to expand this, either by writing it down or in our heads, 5b times 2ab. 5 times 2 will give us the 10 at the beginning. The a will go in the middle, and then the b times b will move to the end and give us the b squared. For the second term, 5b times the 3 will give us the 15b, and there is the minus 3 there, giving us the minus 15b. What we've done is we've started with a slightly more complicated example, 10ab squared minus 15b, and by going through this process of factorising, we've got to the bracketed form of 5b and 2ab minus 3 in brackets after that.